Hello, if you do not already know me, my name is Bree. I am a sophomore chemistry student and this is going to be my 2020 final. Obviously, the ideal parameters for this experiment would have been a controlled environment like the classroom where we would have had good ventilation and safety precautions, but due to coronavirus, I couldn't exactly make that happen. So before I get started with any of this, I wanted to just do a quick disclaimer. This is very dangerous. Please do not try it at home. Cyanide can be absorbed through your skin and it can ultimately kill you. And we're dealing with sulfuric acid. Nothing bad happened, so I got off lucky on that one. So once again, just do not try this at home. However, though, I am going to be doing this in the form of a lab report-ish type video. So I'm going to have my hypothesis, my list of materials, and at the very end I'm going to show some stuff or share some information that could have helped me do better in the experiment, or what I could have done differently to better the experiment or get a better outcome. Well, now that I got that out of the way, let's get started. Okay, so the purpose of this experiment was to use the metal displacement theory to effectively recover gold from potassium cyanide gold plating solution. My hypothesis is the theoretical yield of refined gold in the solution is 11.66 grams, and the actual yield of the product is expected to be as close to the theoretical yield as possible. My materials were an aqueous solution of 68.3% potassium gold cyanide, 325 mesh zinc powder, sulfuric acid, glass stir rod, beaker, filter, hot plate, and proper personal protective equipment, which actually includes good ventilation. To start off the experiment, we took a hot plate and we calibrated it to find out where it would heat a solution to 60 degrees Celsius and stay there. After calibrating the hot plate, we took a beaker and we poured the bottle of potassium cyanide solution into the beaker. My theoretical yield of gold that we should have gotten was based on the calculations of having 150 milliliters of the potassium gold cyanide solution. I actually had to estimate the 150 milliliters to start off with because the bottle originally had 200 milliliters of the solution in it, and it was about 3/4 of the way full, so I assumed, okay, that's about 150 milliliters. I was slightly off on that because when I put it into the beaker, it measured to 183 milliliters, and I just went with it because if we were going to get gold out of it, I really didn't want to waste any. So we heated the solution to 60 degrees Celsius, and then we added 1 gram of zinc. After we added the zinc, we would stir it for 5 minutes, wait an hour, stir it another 5 minutes, and we repeated that process 4 more times. So that would make a total of 5 times you would stir it. And then I was directed to actually leave the solution overnight and let it precipitate. So the reason why we actually added the zinc into the solution is because it is a simple replacement reaction where the gold is precipitated out of the cyanide solution and is replaced with the zinc. So it is the next morning and we checked on our solution, and to my surprise there was actually a lot of gold sediment at the bottom. But the issue with this gold sediment is it still has zinc impurities in it, and to get that out we're going to use sulfuric acid. So we originally bought 18 molar sulfuric acid, and we soon realized that we didn't need 18 molar sulfuric acid, and we actually need dilute sulfuric acid. The definition of dilute sulfuric acid is actually 1 molar or less, and since we had 18 molar, there was some dilution that needed to happen. So we diluted it by adding 2 milliliters of the 18 molar sulfuric acid to 6 milliliters of water. And then we continued to add more water until it got to a total of 50 milliliters of water. The goal of adding the sulfuric acid is to dissolve the zinc and leave us with some pretty refined gold. So as seen in this picture, you can see we have our little fume system set up. It was actually sucking the air and we made sure that we didn't have any fans running to disturb the air around it. So we set up our beaker of our gold with the zinc impurities, and we poured the 50 milliliters of sulfuric acid diluted into there, and we put a flame under it just to speed up the reaction, almost as like if it were a catalyst. So we left that there for about 10 to 15 minutes to completely do its thing. The reaction that just took place was an exothermic reaction. I actually learned something. And what that means is it put off a lot of heat. So we started off with that gold that had the zinc impurities, and when we added the sulfuric acid and water, what was produced was zinc sulfide and hydrogen. And of course, you're going to have the refined gold dust. So after we filtered off that sulfuric acid solution, we rinsed off the gold with water a few times, just to make sure that the sulfuric acid was completely gone. Also, when we had the sulfuric acid, we made sure to have baking soda around in case anything happened. The reason we have baking soda is baking soda makes the effects of sulfuric acid inert, and it's just there for safety precautions. So now that we have our gold dust, and it looked kind of like dirt, I was kind of sad. It wasn't like glittery or anything. We needed to figure out what we're going to do with it. How are we going to melt it? Okay, so at this point we did not know how to melt the gold, and then my dad did some research, and he found out that you can make a crucible out of a potato. If you didn't know what a crucible is, it is traditionally a porcelain or some other type of good material that won't melt under high temperatures. And it's used for melting like metal, making jewelry, sometimes even glass. So apparently when you put the potato under high heat, it takes away all the moisture and turns into carbon. So it makes the perfect type of container to melt things in. So in this picture right now, you can see what he did with the potato. He cut out a little hole in the inside, put some borax in there, and poured the gold dust and a little bit of borax on top. And then we put it under the flame. So using our torch and MAP gas, we lit that potato on fire. So apart from the fact that it smelled like a burnt McDonald's afterward, it was effective and we had melted gold in there. And it didn't really melt all into one chunk. There was a pretty decent sized chunk, and then there were a bunch of little balls on the inside of the potato. And the downside to using this method is with the borax melted into a type of glaze over the gold, and it didn't really affect much during the weigh-in process because it does not have that much mass to it versus the gold, so give or take like maybe a tenth of a gram. And it's not really that much. Otherwise, there was some ash from the potato left on the gold. We did what we could to get that off, and we even boiled it some to try and get it off. And then we did our final weigh-in. So we used our little scale and we weighed the amount of gold at the end, and it was a whopping 4.43 grams. Now, if you remember from the start, my hypothesis said that the theoretical yield was 11.66 grams for that amount of cyanide we had. And obviously, this wasn't even close. So, because the cyanide solution was about 30 years old and was already partially used, there are several things that could have caused this experiment to come out the way it did. One theory, and this is a theory my dad gave me, is imagine, because this stuff was used for gold plating electronics. So imagine they pour some out into their gold plating dish, and they plate something with gold, and then they just poured it back in. When you pour that empty solution back in, that's obviously lessening the amount of gold that is in that entire bottle. And that is a very highly possible thing that could have happened. Another very highly possible thing that could have happened is the calculations that were made could have been inaccurate. The calculations I'm referring to in specific are the calculations that told us the amount of zinc to put in. Every atom of zinc replaces 2 atoms of gold. And of course there's like different weights, yada yada yada. I'm just wondering, what if we had added more zinc? Would it have produced more gold? or had more gold to displace. There's really many things that could have affected the experiment and the way it came out. Like, what if I had left it there longer? Increased the temperature, decreased the temperature. Maybe I didn't stir it enough. But still, given the situation I was in, doing it at my dad's workplace, and without the help of an actual instructor or my teacher, I'm pretty impressed. I'm pretty proud of myself and what I got out of this. I know it doesn't seem like much, and it's kind of lame that I didn't get the expected outcome of gold, but at the same time, I just got gold out of cyanide. So it's kind of a win. I also wanted to say thank you to Dylan for helping me with this and enduring this with me. He did most of the calculations, a lot of the math. I just kind of trusted him and went with the flow of it, because that is a area where I'm not particularly strong in. Anyway, it was a big help having Dylan, and yeah, thank you. Anyway, so I hope I didn't bore you guys too much, and I hope this was somewhat informational. Hey, maybe you learned something today. I hope you guys have a nice rest of your day, and stay safe during quarantine. Goodbye.